CNS is the Center for Nanoscale Systems, a part of Harvard University. CNS is set up to serve our research community by providing shared facilities for state-of-the-art research. CNS is open to all scientists. About 1,000 Harvard students and postdocs work here, and about 500 researchers come from other universities and from companies, both large and small.
I'm a fifth-year graduate student here at the School of Engineering and Applied Sciences at Harvard University. I work with the group of Professor Federico Capasso in Applied Physics. The Capasso group covers a wide range of topics in the study of optics in general, including the study of the quantum cascade lasers and also their applications, electrodynamical forces, and also various nano-optics and nanophotonics, especially plasmonics, which is the interaction of light and nanostructured matter. At CNS, in particular, I use a lot of tools such as electron beam lithography, physical vapor deposition systems such as electron beam evaporators, sputterers, and also chemical vapor deposition systems. Recently, I've needed to install a temperature control stage inside a scanning electron microscope, and the fact that I've been allowed to do that and the staff have been helpful in helping me do that has been very instrumental.
What I really like about CNS is just the sheer collection and diversity of really state-of-the-art instrumentation that they have in both fabrication and characterization. I'm working on the development of a colorimetric indicator for liquids that operates based on wetting. In contrast to pH paper, where the color of a particular region changes in response to pH, in our case, it's really a pattern that is appearing. It's not only can we control what liquid induces a given pattern, but we can control what those patterns are. And that really enhances the user friendliness. So for example, we can make the word methanol appear in response to methanol. This type of a really broad state-of-the-art user facility allows your research to grow and evolve while still being able to leverage the equipment that they have here. And that flexibility is something that's really valuable to cutting-edge nanoscience.
Essentially, every activity that we do in my research group would not have been done without the CNS and the facilities that are available at CNS. All those characterization tools like electron microscopy and other types of characterization tools, lithographic tools so that we could fabricate devices in nanoscale structures. It is truly instrumental for my research group.
Throughout the course of the research that I've done here at Harvard, I'd say I've used about every machine in this facility. We're making a toolkit for cells in the same way that a doctor has a toolkit for studying your body. And it turns out, because of the size of an average cell, which is about 10 microns, that we need to make structures that are on the size of microns to nanometers. And it turns out that this technology that we've been doing has been successful enough in perturbing cells that it's opened up new avenues of biological research. So these little needles that we've started creating, these nanowires that are coming off the surface of silicon wafers, are now being used at other institutes, for example, the Broad Institute over by MIT.
The tools and facilities at CNS have proven to be valuable across many fields, ranging from physics, chemistry, biology, and even medicine. Researchers in companies gain access to tools that they may not have in their own facilities. Small companies may not afford to have these large instruments, and even large companies come in and use them when they're not available in their own sites.
MC10 started using Harvard CNS in 2009, and it's a great vehicle for us to do our early development and rapid prototyping. Our team's going to have an idea on the whiteboard early in the day, and it's kind of start to put it to practice by the end of the day. MC10 is working on a renal denervation catheter, so it's basically a small balloon that inflates inside the body, and we're putting electrical sensors on the surface of that balloon in order to allow us physicians to collect data inside the body and deliver treatment. CNS has greatly enhanced our work by allowing our guys to get in here and almost have uninhibited access to great equipment, technology, and be able to really do rapid innovation and rapid product development. So we start to develop it here in the lab, and then we start to shift it off to manufacturing as fast as possible. And CNS is a great enabler of rapid innovation and rapid development.
Lilliputian Systems is a reasonably well-funded venture-backed startup. But even with all of our funding, there are times where we require outsourced services for a number of our wafer fabrication needs. Rather than go through the expense of building those facilities out and manning those facilities, having a relationship with Harvard CNS allows us to use them in a cost-effective manner. It's a wonderful system, and we're focused exclusively on solving the world's biggest problem, portable power issues with all of your consumer electronics devices. Our core technology is a solid oxide fuel cell that we've been able to imprint directly onto a silicon wafer. And we expect this technology to transform the way in which people interact with their consumer electronics devices. Like any startup company, intellectual property is core to who we are. We wouldn't engage with any entity unless we felt that our intellectual property was secure. And at Harvard CNS, we absolutely feel it's secure. It's a pleasure to work with Harvard CNS.
Not only there is a wonderful facilities out there so that we can do a wonderful science, but the fact that we can freely exchange ideas and then use that exchange in order to better our science.